Here's a problem for you to try. Let's take a look. It says find f prime of x using the definition of derivative if f of x is equal to the square root of 3x minus 1, where x is greater than 1/3. So let's take a look at that. First of all, recall that the definition of derivative can be written in different ways, but we'll choose one of those. It's the limit as h goes to 0 of f of x plus h minus f of x over h. And it's your job now to go ahead and take this function and plug in x plus h, x, set up this fraction, and then do some algebra to see what you get. So we're going to pause the video here to give you a chance to go ahead and see if you can do this problem. If at any point you're stuck, there will be hints taking you all the way through to the final answer to the problem. We're going to go ahead now and plug in x plus h and x using what we know about function notation. So let's see what we get when we do that. We get the limit as h goes to 0 of, well, what is f of x plus h? Again, remembering that a function is like a machine, and wherever we see the x, we drop in whatever occurs inside the parentheses. So this is going to give us the square root of 3 times x plus h, that whole quantity, minus 1. That's f of x plus h, minus just f of x, which is the square root of 3x minus 1, all over h. Now, if we go ahead and simply let h go to 0, let's see what happens. If this goes to 0, well, and this goes to 0, what do we get? Well, here we get 3x, right? The h goes away, so we get 3x minus 1 square root minus square root of 3x minus 1, and that gives us 0 over 0, which is undefined, so we have to do something to get us out of that jam. And the next thing we want to do is go ahead and rationalize the numerator. So we'll stop the video, give you a chance to do that, and see you back here if you still need more help. Now let's go ahead and rationalize that numerator, remembering what that means. So we're going to rewrite the expression that we have. There it is. And rationalizing means taking the same expression but changing the sign in the middle of those square roots. So that's multiplying by the conjugate. So that means we're going to multiply numerator and denominator. You can't just multiply one thing by that same expression with a plus. So here we have it. Why do we have to do numerator and denominator? Well, that's because we can multiply by 1, but we can't just multiply something by any arbitrary expression without changing what it is. So now we have that, and let's recall what we do next, or think about what we do next. We now have an expression that looks like, in the numerator at least, a minus b times a plus b, and remember that's the sum and difference of two quantities, and that when we FOIL that or expand it gives us a squared minus b squared. So I'm going to stop the video and give you a chance to go ahead and apply that to this and see what you get. Now we're going to use this formula and substitute these expressions for a and b, and we get a squared minus b squared, which is going to be the square root squared, which is just the expression underneath. So we get 3 times x plus h minus 1 minus, and this is b, and so b squared is 3x minus 1. That's the numerator. over h times this entire expression, the square root of 3 times x plus h minus 1, plus the square root of simply 3x minus 1. So now we have combined those fractions, and we can do a little bit of simplifying. Let's use the distributive law here. We get 3x plus 3h minus 1 minus 3x, distributing this minus, plus 1 over the entire expression, h times the square root of 3 times x plus h minus 1 plus the square root of 3x minus 1. And there's some good news here. We can cancel some things. The 3x's cancel, the 1's cancel, and notice that what's left in the numerator is 3h, and so the h's cancel, and that leaves us with 3 over the square root of 3 times x plus h plus 1 plus the square root, sorry, that's a minus 1. We can fix that. That's minus 1 plus the square root of 3x minus 1, and now we'll pause the video and allow you to take the limit as h goes to 0. To finish the problem, recall that the derivative was the limit as h goes to 0 of f of x plus h minus f of x over h, and we've seen that that is 3 divided by the square root of 3 times x plus h minus 1 plus the square root of 3x minus 1. And now we're going to let h go to 0, so the only place h occurs here is in the denominator. We let that go to 0, and let's see what's left. All that's left is 3, so we're taking the limit now, divided by, here we just get the square root of 3x minus 1. The h is gone, plus the square root of 3x minus 1, and that is 3 divided by 2 times the square root of 3x minus 1, because there are 2 of these. We could write that a little bit differently if we wanted to. It's 3/2 times 3x minus 1 to the minus 1/2, and you might recognize this form if you differentiated this without using the definition, but simply used power rules and the chain rule. So that's this problem. Hope you had some good luck with it. If not, we'll see you elsewhere and see if we can be of further help. So, bye for now.